Hi everyone, this is Mrs. GA, and today we're going to learn how to find the surface area and volume of a prism. So let's talk about what a prism is. It is a three-dimensional shape. Here's an example of what one could look like. So a few characteristics. The bases of a prism must be parallel and congruent. So you can see here we have one base that's a pentagon here, and here would be the second base. And when we're drawing three-dimensional images, we use those dotted lines to show lines that are there, but we wouldn't really be able to see them in real life. So you can see this is kind of going back, and it's actually behind the prism. The lateral faces are the faces that are not the bases. So again, the pentagons are the bases. So those 5 rectangles that go along the sides, that would be those would be the lateral faces. The lateral faces intersect at what are called lateral edges. So here, 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 and here, and they're always going to be parallel. And last, the altitude of a prism is a segment that is perpendicular to the bases with an endpoint on each base. So you could use one of the lateral edges as an altitude. So there are 2 formulas we're going to be working with today. First is the formula to find the surface area of a prism. So the surface area would be the area of all of the outer parts of the prism. So it'd be the area of all of the lateral faces in addition to the top and the bottom. So you can find the surface area by finding the lateral area plus 2 times the area of the base, because there's 2. The lateral area, you'll notice in this case it's just a bunch of rectangles, can be found by taking the perimeter of the base. So you add up the sides of the base and then you multiply it by the height, and that would be your lateral area. We're also going to be finding the volume of the prism. So the volume of the prism can be found by finding the area of the base. And we did cover in the last video how to find the area of regular polygons like pentagons. So we'll need to use that times the height. So those are the 2 formulas we'll be working with today. Okay, so in this first example, we're going to be finding the lateral area of each prism. So remember, the lateral area is just the area of the sides that aren't the base. So we're actually going to be leaving out the 2 bases because it's not the full surface area. So the lateral area can be found, remember, by doing the perimeter of the base times the height. So you can see that our base here is a hexagon, and it has a side length of 5. So we can find the perimeter of this base by simply doing 5 times 6, which is 30. And then we can see the height of our prism is 12. Now, I know this is kind of weird because we usually think of height as up or down, but in this case, height is just the distance between the 2 bases. So even though it's sideways, we're still going to consider it the height. If you do 30 times 12, we get a lateral area of 360 centimeters squared. Remember, area, we always have our units squared. Okay, so now we're going to find the lateral area of this prism. It's a triangular prism because the bases are triangle. So again, we're not going to be finding the area of the bases. We're just finding the area of the lateral sides. So again, it's going to be the perimeter of the base times the height. So we can see here that we have one side of our base, but we do need to make sure that we find the other sides. So here we may need to do a little bit of trigonometry. So let's imagine we take this right triangle, and since it is being bisected here, we can call each of these halves 6 and 6. And then we do want to find this length. So since this is a right triangle, we can use the Pythagorean theorem. So we can do 6 squared plus 8 squared equals x squared. So x is going to be the square root of 6 squared plus 8 squared. So this actually becomes the square root of 100, which is 10. So we know that this side length is 10 and this side length will be the same. It will also be 10. So we can see that the perimeter of our base the perimeter of the base is going to be 12 plus 10 plus 10. So it's 32. And now we have enough to find the lateral area, which remember is the perimeter of the base, which is 32, times the height, which remember is just the distance between the bases. The height is not always going to be vertical, so our height in this case is 10. So our lateral area is 320, and we'll say units squared. So now that we've done lateral area, we're going to try to do the full surface area of each prism. So here, in this first example, we have another triangular prism. So these right triangles are our bases. So first, we are going to need to find the area of our bases, and then we'll also need to find that lateral area. So one thing we can start by noticing is, since this is 30, this line is also 30. And then we can find this last leg of our triangle using the Pythagorean theorem. So we can say 18 squared plus a squared equals 30 squared. So a is going to be the square root of 30 squared minus 18 squared. So notice I just subtracted 18 squared, and then I took the square root of both sides. And we find that that last side length has a length of 24 inches. 24 inches. Okay, so just a quick reminder, our surface area, maybe I'll write it up here. Our surface area formula is going to be the lateral area, which we just practiced finding, plus 2 times the base area, because there are 2 bases. So let's start by finding our lateral area. So remember, the lateral area is going to be the perimeter of our base. So we do 18 plus 24 plus 30 to get a perimeter of 72. So it's the perimeter times the height, which in this case is 15. So our lateral area is 1,080 inches squared. And then we can find the area of the base. It is a triangle, so in this case it's going to be 1/2 times the base times the height, and they are perpendicular, so they will work for this formula. So times 24 times 18. So the area of one base is 216 inches squared. And now we need to find the total surface area. So the total surface area is going to first be our lateral area, 1,080, plus 2 times the area of our base. So remember, for surface area, you're trying to find the outer area of every single side of your prism. So this formula takes that into account. So our total surface area is 1,512 inches squared. Okay, let's see if we can find the surface area of this next prism. So this is actually the same prism that we found the lateral area for previously. So this was that second example that we did. So we already found that the lateral area here was 320 units squared. So now that we already know the lateral area, all we need to find is the area of the base. So let's do that. Of the base, again, we have a triangular prism, so it's going to be 1/2. This is our base, and this is our perpendicular height. So we get 48 units squared. And now we can use our surface area formula. So we get the lateral area, again, 320, plus 2 times the area of our base, which was 48. And that gives us a surface area of 416 units squared. All right, so now we're going to move on to finding the volume of each prism. So remember, the volume of a prism, I'll write it up here. The volume of a prism can be found by doing the area of the base times the height. So in this first example, here our base is a triangle. So let's find the area of the base. So 1/2 times the base times the height times 10 times 12 gives us 60 centimeters squared. We can see that the height of our prism is 25 centimeters. So that means that our volume is 60 times 25. So that gives us a volume of 1,500. And for volume, since volume is measured in 3 dimensions, our units are always going to be cubed. So in this case, it's centimeters cubed. Okay, and now let's move on to this last example. So this is a figure from a previous problem, but we still do need to find the area of this base, our hexagonal base. So remember, the way we do this is, well, our formula for the area will be 1/2 times the apothem times the perimeter of the figure of the polygon. So remember, we need to find that apothem, which is going to be this line in red right here. So for this, we are going to need to first find how many, what the measure of each angle is. So remember, we use our n-2 times 180 to find the total sum. So 6 minus 2 times 180 is going to be 720. And then we divide it by 6 and we get 120 degrees per angle. So that'd be like from here to here is 120 degrees. However, when we draw this line here, it's going to bisect the angle. So it's going to give us an angle of 60 degrees. So here we do have a little right triangle. I'm going to redraw that right here. And again, our goal is to find this height. That's our apothem. And all we know so far is that this is 60 degrees. Well, we also see that this total side length is 5. So if you cut that in half, this gives us a side length here of 2.5. So again, I'm taking this right triangle and I drew it a little bigger over here. Again, our goal is to find that apothem. So here, let's use a tangent ratio. We can say the tangent of 60 degrees. So remember, tangent is opposite over adjacent. So A over 2.5. So A equals 2.5 times the tangent of 60 degrees. And you can get a decimal approximation for that in your calculator. So it's approximately 4.3 centimeters. So again, that's our apothem. So now we can find the area of our base. So the area of our hexagon is going to be 1/2 times A, which is our apothem, 4.3, times P, which again is the perimeter of the base. So 5 times the 6 sides gives us a perimeter of 30. So we can find the area of the base. Let's get a decimal approximation for that. We can get 64.5 is the area of our hexagonal base. So the volume is going to be the area of the base, 64.5, times the height, which is 12. And that gives us a total volume of 774, and then we'll say centimeters cubed. So again, if you need a refresher of how to find the area of any regular polygon like this hexagon, make sure to go back and rewatch the previous video. All right, that is all for today's lesson. Thank you so much for watching.